Science is an organized way of gathering and analyzing evidence about the natural world, and science is a process, not a thing. The word science refers to the body of knowledge that scientific studies have gathered over the years. The goals of science are to provide natural explanations for events in the natural world, to use those explanations to understand patterns in nature, and to make useful predictions about natural events. Much of nature remains a mystery because science never stands still. Almost every major scientific discovery raises more questions than it answers. This constant change shows that science continues to advance. Uncertainty is part of the scientific process and part of what makes science exciting. There is a general style of investigation that we can call scientific methodology. Scientific investigations begin with observation, which leads questions that no one has asked before. After this, scientists use further observations to make inferences, which are logical interpretations based on what scientists already know. This and a creative imagination can lead to a hypothesis, a scientific explanation for a set of observations that can be tested in ways that support or reject. Testing hypotheses often involves designing an experiment in which only one variable is changed. All other variables should be kept controlled. This type of experiment is called control experiment. The variable that is deliberately changed is called the independent variable. The variable that is observed that can change in response to the independent variable is called the dependent variable. An experiment is divided into control and experimental groups. Scientists make detailed records of experimental observations, gathering information called data, which can be divided in quantitative and qualitative. Quantitative means numbers and qualitative means characteristics. Scientists use experimental data as evidence to support, refute, or revise the hypothesis being tested and draw valid conclusions. Good scientists share scientific attitudes that lead them to exploration and discovery. Curiosity, skepticism, open-mindedness, and creativity help scientists generating new ideas. Technology, science, and society are closely linked. Discoveries in one field of science may lead to new technologies. Technological advances can also have big impacts on daily life. Communication and sharing of ideas are vital to modern science. Scientists share their findings with the scientific community by publishing articles that are undergone peer review. In peer review, scientific papers are reviewed by anonymous independent experts. Publishing peer-reviewed articles in scientific journals allows researchers to share ideas and to test and evaluate each other's work. Evidence from many scientific studies may support several related hypotheses in a way that inspires researchers to propose a scientific theory that ties those hypotheses together. In science, theory applies to a well-tested explanation that unifies a broad range of observations and hypotheses that enables scientists to make accurate predictions about new situations. A useful theory that has been truly tested and supported by many lists of evidence may become the dominant view among the majority of scientists, but no theory is considered absolute truth. Using science involves understanding its context in society and its limitations. When scientists explain why something happens, their explanations involve only natural phenomena. Pure science does not include ethical or moral viewpoints. The way that science is applied in society can be affected by bias, which is a particular preference or point of view that is personal rather than scientific. Biology is the study of life, but what is life? What distinguishes living things from non-living matter? Well, living things are made up of basic units called cells, are based on a universal generic code, obtain and use materials and energy, grow and develop, reproduce, respond to their environment, maintain a stable internal environment, and change over time. The study of biology revolves around several interlocking big ideas. The cellular basis of life, information and heredity, matter and energy, growth, development and reproduction, homeostasis, evolution, structure and function, unity and diversity of life, interdependence in nature, and science as a way of knowing. Living systems range from groups of molecules that make up cells to collections of organisms that make up the biosphere. Biology includes many overlapping fields that use different tools to study life from the level of molecules to the entire planet, like global ecology, biotechnology, building the tree of life, ecology and evolution of infection diseases, and genomics and molecular biology. Because researchers need to replicate one another's experiments, and because many experiments involve gathering quantitative data, scientists need a common system of measurement. Most scientists use the metric system when collecting data and performing experiments. Because the metric system is based on multiples of 10, it is easy to use. Scientists working in a laboratory or in the field are trained to use safe procedures when carrying out investigations. Careful preparation is the key to staying safe during scientific activities. The single most important safety rule is to always follow your teacher's instructions and directions. And because you may come in contact with organisms that you cannot see, it is essential that you wash your hands thoroughly after every scientific activity. Finally, about science, there is a quote I want you to remember. Science will keep changing as long as humans keep wondering about nature.